Hello, this is part 2 about load balancers. And here we talk about layer 4 load balancing, as previously we focused on more the layer 7 or HTTP/HTTPS load balancing. There's actually 4 flavors of these layer 4 load balancers. Maybe the simplest one is your internal TCP UDP load balancer. Matter of fact, actually, now that I think about it, I'm going to open up. Easy way to remember all this is there's a tool or there's a page here talking about choosing a load balancer. And you'll see, I think I've seen this, we've seen this before, but there are actually, there's a decision tree about which ones you should be using. And I'll just use this as to help explain it. So first of all, from an internal perspective, so if you're load balancing internal traffic, there's only one choice, and that's the internal internal TCP UDP load balancer. And you can see that that's basically your only decision. And yeah, that's that. Key aspects of this, it's regional. So that like you have to run this at a regional level, and it's a pass through. So essentially the client IP addresses that, hits this load balancer get passed through to the endpoints. Okay, so that's the first one. The second one that's similar to it, it's just the external version of the same thing. So basically it's a pass through. You can use UDP or TCP traffic, and but it has an external IP address instead of an internal IP address. So virtually the same thing, regional pass through. Then there's 2 proxy versions. So when I say proxy, it means it's not a pass through essentially. So you don't get the client IP. Basically the load balancer creates its own little addresses it uses to communicate the back ends. That's the proxy part. The reason why these are nice, so they're a proxy, but the good news is that they can be global. So that's kind of one of the reasons why you do global. And the 2 flavors of them is one is just straight TCP, and the other one is SSL proxy, which basically you offload the SSL work to the load balancer itself, as opposed to doing it yourself. Okay, so those are the flavors, and we're going to focus primarily, just for simplicity, we're going to focus on the internal TCP UDP load balancer and in our example. Okay, so let's switch gears. I'll close that window, scroll down. This is the sort of the diagram of what internal TCP UDP load balancer looks like. And so I'll just follow the flow, right? So basically the load balancer exposes an IP address. That's its forwarding rule, right? That's inside your own subnet, right? So that's what you hit to get to the load balancer. It goes into load balancer and it pops out. And you can see that there's no, like the other one had all the complexity diagram of all the proxy stuff. There's no other proxy subnet floating around. So basically the traffic gets dumped back on your subnet and right onto your instances. We'll talk more about what all that, the implications of some of this in a little bit later. Okay, so let's keep on going. Yeah, so we actually just go through an exercise of doing this. Now, let me set up what our end game is here. Our end game is we want to create service here that uses TCP or UDP, right? But it's not HTTPS, so we can prove that we can actually use this for something real. I think the simplest example I could think of is a DNS resolver. So it's basically a DNS server that will answer DNS queries, and not necessarily serving its own domains, but like a recursive resolver. So it will answer questions about like Google or whatever you want to ask it. It will answer questions for DNS for you. And we'll install a piece of software that does that. And the key here, it runs on UDP port 53. So it's very different than, right? I mean, it's UDP and it's not HTTPS is the point. So that's a good example of something that would need to use a TCP UDP load balancer. Okay, so the first thing is we do not need to create a firewall rule. Like in the previous example, we had to create firewall rules around the proxy subnet. Well, in this case, the traffic will be coming from an IP address that's basically internal, right? It's a look like the traffic's going to be coming from an internal address, and so there's no proxy subnet. So we don't have to create special rules to allow that port 53 traffic into our instances, because there's a default. I guess we should look at it. Let's go to the firewall rules. Let's see if I can get to it. I got to go under VPC network firewall. So actually I left. Okay, ignore this top one. We'll look at this one in a minute. So the default 4 you get when you create a default VPC are these 4 down here, and one of which is default allow internal. And you can see it basically applies to all instances, and it basically says anything that's coming from the 128 address, 10.128, which is basically the entire subnet for the VPC, just allow any port, any UDP or TCP, just allow it in, right? So that's already in place. So it's kind of like your internal network's pretty soft. Anything can talk to anything. So this rule is why we will be able to not have to create any special rule to allow the traffic to get to our DHCP servers, right? But there's one rule that we do need to create, because we'll need to create a health check. In this case, I'm going to use a health check that runs on port 80. Some little web servers for my health check, partially because this is a sidebar. We'll have to create a health check, and I wasn't sure if Unbound itself provided anything that ran on TCP, because it by default DNS runs on UDP port 53. So I needed to have some mechanism to do health checking. There's no concept of health checking with UDP. So the solution here was I just ran a little web server, ran it on port 80 as my health check. So it's kind of a, conceptually you would have probably a more sophisticated health check than just running a web server there. But either way, so the key here is by default, you don't get this allow health checks. So you basically need to allow your instances. In this case, I just said any of them. You need there's certain IP addresses that you need to allow traffic in, and it's in the documentation for load balancing. There's these two subnets. They're Google subnets that basically do your health checking, and you need to allow them to talk to your box basically. So I had to do this to get and we did this in the previous example too, just as a reminder. Okay, so that's it for firewall rules. Basically with this, just one rule are ready to go. Okay, so let's go. Firewalls done. Okay, so now we need to create the actual instances that will run our DNS resolvers, right? And I'll talk about the script as we get to that point. So let me go through the exercise of creating. So I got to create the managed instance group. So before I do that, I got to create the template. So if I go to VM instance templates and create. Okay, so I think I'm already running a NAT, FYI. If I was from the previous video, I'm going to create these with internal IP addresses only, just because it's the right thing to do. But in order to do that, I had to enable a NAT. So I already left the NAT running. I didn't turn off from the previous video. So just imagine you already have a NAT running in this region that you're going to create these boxes in. So which is, I'm always using US Central 1. So my template's here. And the two things I need to do is one, I want to make this not have a public IP, and external IP, none. But I also need to have some software running on this box. And unlike the earlier video, I'm not using any under networking. I didn't use any tags because I just had the filter. This time I just set up the firewall rule to use all instances. So I don't have to create any tags, network tags. But I do need to copy this, and then we'll talk about it as I paste it in. A startup script. So it's paste. Okay, so let's see if I can make this big enough so we can actually read it. Okay, so this should look familiar, right? This top part, this section is just running my web server, right? So that's again for the health check primarily, because I needed something that I could actually hit that would be valid health check. But here I'm installing the software is called Unbound. It is basically a relatively simple DNS resolver. So it'll basically resolve DNS queries for you. It doesn't necessarily serve them itself. It's primarily there to be a resolver. But there is two changes you need to make to the configuration. So I'm adding 2 options to its configuration and then restarting that Unbound. And the first one is fairly straightforward. By default, Unbound will not listen to, will not allow any, won't resolve anything. By default, it has an implicit deny rule. So you basically need to say, hey, you're going to allow any IP addresses from, and this is the entire VPC subnet. Basically allow it. So that's the first one. That's pretty straightforward. And we'll talk about this interface automatic. Yes, it's pretty subtle, but we'll talk about that shortly, like why I needed that. And see if we can explain that properly. So again, I got my script and I have an internal private IP address. So I hit create. That just takes a second. In fact, it should be already here. So the next thing I need to do is create a managed instance group that uses this template. So I need to go down to manage instance group. Of course, I can't find it. Here it is. Create. And I'll just call this group 1, multiple zones, central 1. It's basically, the key here is it has to be in the region. We're dealing with a regional resource, so everything needs to be in a region. So in this case, I'm just using US Central 1. I need to use that template. And just because, so I'm using autoscale, I'll leave everything default, but I'm gonna want to at least have 2 instances just to make it more meaningful. I'm gonna leave everything alone. I'm not gonna use any health check for auto healing for now. So I hit create. Now I'm gonna pause the video because this takes like 2-3 minutes, and then we'll dive a little deeper into some things you need to know specifically about your instances to get them to work with a pass-through load balancer. That was pretty subtle. It took me some time to figure out. So let me pause the video. Okay, it didn't take that long. Instance group is up and running. You can see that it's healthy. I think you can see that there's 2 instances, right? And yeah, here we are. I need to build a secure shell into one of these to explain the next thing. So so these have private IPs, not public IPs. So I have to well, that's okay. Let me go. I need to secure shell onto it. That UI was broken. So details. I know what I need to do. I need to go to VM instances. Let's do it this way. So I must have left an old instance floating around. We'll use that later for trouble or for something else, but I'll leave that one around. That's just a basic instance I just created with nothing special on it. These are the 2 that I got created, and I think there's an option where it says view gcloud command. Copy this. So this allows me, because I have a private IP or internal IP, I can't just secure shell into it normally. So I have to run the gcloud version of it, which will basically tunnel my traffic through Google's network, I guess. But I can basically log into the without having access to a public IP. So I'm in the box, and I'm going to look at a couple things. Go back to my docs here. Okay, so this took me a lot of time to get straight because there's some things that are important to know about getting the stuff to work this client pass through, right? So the first thing, here, let me tell you the nut of it, and I'll talk about how it gets solved. So the problem is when the traffic goes through the internal load balancer with this client pass through or pass through mode, it basically goes through the load balancer, right? And when it hits your box, a couple things are in place. One is the client IP, the source destination for the packet, right? The source is still the client, which is fine. That's nothing special. And so your box gets a packet or gets the request looking like it's coming from not through a proxy through the load balancer, but from the original client. Okay, so that's not the hard part. The hard part is the destination IP address, right, of that packet is not the IP of the box, your box. It's of the load balancer endpoint. So your box is now getting basically a request from a client IP, but the destination is not you, the box, it's rather the endpoint. And somehow your GC instance needs to be able to recognize that, oh, I'm supposed to take this packet and do something with it. Because it doesn't, at first blush, it's not, looks like it's not destined for my GCE instance. So in order to make that work, the first thing is your operating system needs to kind of know something about that IP address. And yeah, so the load balance, your instance needs to know that it's supposed to accept packets essentially for the load balancer's IP address. And to make that work, and I guess I can't do this right now because I don't have the load balancer set up yet. We'll have to come back to this later, but if I can remember. But the key here is when you use an image provided by Google, they actually run software on your box automatically. And it's called basically the guest environment. So some software is already installed. And one of the functions that the guest environment does is when you set up a load balancer, right? Basically through this guest environment, it basically populates a route table on your box for the load balancer. So basically it says, hey, basically what this is doing is telling the operating system, hey, I have a way of handling traffic for this load balancer IP. And basically it points to itself. So, and that means now when traffic comes onto the wire that says, hey, it's for this IP address, this particular instance says, hey, I know how to handle this because I have a route for it. So that's what essentially this will do. And we'll have to come back and look at this, right? So that's the first part of it. Good news, that's all automatic. That wasn't where I got stuck, right? The next part is because the packet is destined for, and we'll look at this shortly too. Actually, I can look at it now. Because the packet was not destined for your IP, the packet may be on your box, but your software needs to say, hey, I'm listening for basically that IP address, right? And out of the box, most software is not configured to just listen for any IP addresses. It typically listens for IP addresses that it knows about, which is like its own interface IP address or maybe local host. It doesn't just say, I'll listen to any packet or any basically destination IP. So the key here was that this business we added here, this interface automatic for Unbound. In fact, I should bet you I can find the documentation for this. I'll just read you the paragraph, which I probably should have shared earlier. Let's see if I can find this quick enough, or otherwise I'll just unbound, bound, and then I just paste this. Yeah. You find. So the interface automatic, yes, says listen on all addresses and all interfaces. Detect the source interface of UDP queries. So this is, and copy them to the replies. So basically this is saying two things. One, it's to listen for the IP addresses, and separately, more importantly, or not more important, similarly importantly, it basically takes the destination IP addresses for those packets and puts them on the replies, which is what we need to do because from your client perspective, when it sends a request to the load balancer's IP address, it's expecting the response to come from the load balancer's IP address, not from your box. So this actually does all the magic we need to do. It basically automatically does the right thing, essentially. It basically listens for the load balancer's IP addresses, and then two, on the replies, it basically it basically spoofs that IP address on the reply. It says, oh, I'm really the load balancer's IP address when it sends that packet back. Okay, so that was a little bit of a sidebar, but that's been a good part of a couple hours trying to figure out like why my load balancer wasn't working. So to see this in place, let me pause the video because I'll just show you how do you know this is actually doing the right thing. So let me pause the video for a second and find the documentation I needed. Okay, I'm back. Yeah, I had to find that. So I had to remember. So the way you can, there's some TCP Linux commands you can use to see what's listening on what interfaces and what IP addresses. And I basically typed in show ports in use Linux. And here is an article, and I'm going to copy and paste the sudo, well, actually just netstat. I don't know what all these flags are, but I'm going to just copy and paste it. Basically, netstat will tell you kind of what's in use. And let's see if I can make this bigger. And the key here is this line right here. So you can see that unbound is the software I'm listening to, and it's allowing any traffic from any. This is basically the source address, right? But the local address, instead of actually putting in a particular IP, if you didn't do anything, you would see like your IP's address here. It says, hey, I'm going to listen to any address that's on port 53 on UDP. So without that extra setting, like that was the key of adding I can't find it, of course, now. Oh, that was the key to adding this line right here. Without this line, you would not see 0.0.0.0, which basically means any IP address. You would have rather seen your, in this case, I think by default, it only listens on local host. So you'd only see 127.0.0.1, and your load balancer wouldn't work because your software is not listening for the IP addresses of the load balancer. So either way, hopefully it made sense. Okay, let's go back to doing what we really want to do. Okay, I think we're done with that. Yes, okay. So now we'll keep on going. So we need to create a health check first because that's part of the configuration of a load balancer. So we need to go to, I think health checks right here somewhere. Health checks. I guess I already left it in place. So I'll just leave it here. This basically, it's the health checks in my region. Basically just searching on port 80 / that's on basically talk to the Apache server. And basically just says, okay, this is all the defaults. So basically this says it's healthy as long as the Apache server is running. So that's the first thing. So I didn't do it, but you can basically go here and create health check, do the same thing yourself. Okay, so next step is, I don't think I need that anymore. Go back to my documentation. So the health check's created. Okay, now you just got to create the load balancer. And this is the name here I'll use. So let me go here. No, I get too many windows open. So load balancer is going to be underneath network. Network services, load balancing, create load balancer. Oops. Yeah, create load balancer. And I want to do a UDP load balancer, right? So this is internal. And then name. Okay, so that's, so what am I doing? Well, anyway, the name doesn't really matter, but okay, I think that's what I used. I want a US Central 1. It's on my default network. The back end here, this UI is a little weird. You go here, and then you have to jump over here. That's my instance group, health check. I'm just going to use the health check. Then we go to front end, name. I think I gave a name in my documentation, so I might as well stick with it. Back end, front end. Okay. Again, the name doesn't really matter. There's a name, description. I don't care. It's UDP subnetwork. It's going to be on. Basically, this is going to be the same. It's basically the subnet in the same region. In which case, I only have one, so that's why that's there. And then yeah, it's interesting. I just left the default non-shared, so it has its own IP address, right? So it's going to pick an IP address in that subnet, right? It's a single port, and TNS runs on port 53. Okay, and then I'm not going to use this global access thing. It's interesting. It's funny because it's a regional load balancer, but then global access allows, I guess this will allow this IP address to be used. I don't know. I'm not gonna explore that right now. Leave that alone. It's funny because normally I think of this as a regional load balancer, and here they got this thing called global access on here, which it looks like it. I'm curious what that's if I enable it. I don't know. I guess this basically means that I don't know what it means actually. So I think I'm done with this. Review. So I got my front end. It's going to have an IP address on port 53. Back end is my load balancer. I mean, my managed instance group, and then with the health check. Okay, so that's it. Okay, create. Okay, so while this is going, what do we need to check here? So, okay, so we're just going to validate it, but one of the things I'm going to do here is, I think I'm still on my box here. I'm going to pause the video until this loads up because it takes a minute to spin up. And then we'll come back and we'll do some investigation. Okay, I'm back. So the load balancer looks like it's created. It recognizes both instances. They're healthy. And what I wanted to do here was show you the moment you did this, there's an IP address. So I should write this down. Well, I'll leave it on the screen. So what I want to do is from my box, I'm going to see if I can find that command I want to run. I talked about how, here it is right here. When that load balancer came up, it actually did something to my box. If I had ran this before, well, if I run this total, it probably is like a huge list. Well, actually, it's not too bad. So if I look here, see if I can find what's the IP address of this thing. It's 10.128. So it's 195. So if I look carefully at this list, things are working right. It's right here. So 10.128.15, 195. Yep. And so that's the IP address of the load balancer. And somehow my instance now automatically knows about this. And this is basically a route that says, hey, I should be basically, I have a way of handling this IP address, and it should come to me essentially. So that was done by that guest environment. But basically, when the load balancer came up, it talked to Google's metadata endpoint, whatever it is. That added some data there, and then that triggered this box to then create this route. So now this box essentially at the OS level recognizes that it can actually handle traffic for the load, this IP address. And then because earlier, that gets the traffic to the box. And then on the box, this line is what allows this box, and that's something we configured when we configured Unbound, to listen to those IP addresses. So that's just showing you that under the hood, that's all working. So let's see. Let's try a couple things here. Exit out of this box. Okay, so let's validate that this actually does what I'm expecting. So the first thing I want to do is I want to open up a new tab. So what I want to do is I want to log into the extra box I had floating around. Let's see if I can find it. And I want to do some tests with DNS. So this instance, I believe, oh, this box is not, it should have an external IP address. There it is. Okay, so let me log into that box. Okay, so I'm on the box. I don't need the sudo. I think I pre-installed DNS utils, so I can do things like dig. So let's do dig at, move this down because part of my screen is blocked by this thing. Okay, I'm gonna do dig at, and then I'm gonna go over here. So this IP address is here, right? So I'm gonna first just not use the load balancer first, make sure my resolver is actually working. So dig at that. Okay, so this basically, I just said, do a recursive DNS query using this resolver, and that's one of my unbound instances, right? Directly, and I ask for www.google.com, and you see I get an answer. So that's expected, but if our load balancer is working right, I can do that same exact operation. Dig at, of course, this is the moment of truth. Hopefully this all works. It did work earlier, but instead I'm going to use this IP address, which is the load balancer's IP address. And then please work. Okay, it did work. So you can see now I can actually do a query, right, using that load balancer's address and ask a query. So the flow goes, the UDP packet essentially goes to the load balancer's IP address. The load balancer turns around and basically transparently forwards it to your box or back to the network essentially. With the source, the source address is my IP of my instance one. The destination IP is of the load balancer. It puts it back on the wire on that subnet. And because your box has a route for that traffic, it says, hey, I know how to handle that, right, at the OS level. And then your software, unbound software, is configured to listen to any IP addresses. So it says, oh, I can listen to this packet, picks up it, answers the question. It puts the source address now for when it's going back to your instance one. The source address is not the box's IP addresses, but rather uses the load balancer's IP address. In that reply, your box instance one gets back the response. It sees that it's from the address it sent it to, which is a load balancer. So it's happy and gives you the response. So it's a little bit complicated, but it is working as expected. I believe that's all I was going to cover in this video. Yep. Now, of course, I'm going to go back afterwards and tear out the load balancer, the instance group, to take it all out. So I'm not paying money for all this stuff, right? But I'll just do that off screen. So that's it.